Hello, my name is Roberto James Marini of the MaST Research Institute of Sarasota High School. Today, I will be presenting to you my experiment of increasing the stability of an ultrasonic levitator. Ultrasonic technology is used for a wide array of different applications in today's world, be it surgical implements, microgravity experiments on International Space Station, as well as a few others, or the containment and manipulation of various hazardous materials or very delicate materials that simply cannot get into direct contact with most things, such as a countertop or a researcher's glove. However, the biggest problem is finding the optimal frequency for these various applications. True, if you've already done the application, you have a generalized idea of the optimal frequency, but oftentimes for any new experiment or research or application, it has to be done through hours, days, weeks, or even months of trial and error. Some necessary background information. This technology already exists and is already widespread as previously mentioned. There are two different variables involved with ultrasonic technology, the frequency and the wavelength. And these two are directly proportional and inverse from one another. Increase the frequency by 50%, you're going to decrease the wavelength by 50%. The problem with ultrasonic technology is that it's unstable. As you can see here, between the speaker and the reflector material, there are areas of high and low pressure, each one giving off a certain amount of energy. Any cargo you attempt to place inside the ultrasonic levitator will remain in an area of low pressure in between the areas of high pressure. The purpose of this experiment is to find an optimal frequency for the stability of a levitated object inside an ultrasonic levitator. And in doing so, I hope to create a baseline frequency for every single future experiment, application, or bit of research that follows. Now, my goal is to lower the rotations per minute of a microdice in an ultrasonic levitator down to half its original amount. As I previously stated, any cargo, including microdice, that you place inside an ultrasonic levitator will stay in an area of low pressure. However, if the area of low pressure is large between two areas of high pressure, then that leaves plenty of room for the cargo to, to bounce and to vibrate and to rotate between those two areas, thus being highly unstable and just not being able to stay positioned in one spot. So simply increasing the scale to accommodate larger cargo will not work. If you create an ultrasonic levitator the size of an elevator and then place a box of glass inside, once what you get when you get it back out is a box of glass shards. However, if you increase the frequency, you will be able to shorten the wavelength and thus decrease the areas in between the areas of high pressure, thus leaving less room for the cargo, thus probably leaving less room for the cargo to vibrate and to rotate, thus increasing its stability. My methods are as follows. I used an Arduino programmed a computer with the Arduino program installed, along with the apparatus as shown here, including this little chip that basically acts as the Arduino program driver. I then recorded a micro dice being placed inside the levitator for 11 minutes, at which point I uploaded it all to a computer of my own and ignored the first minute of the recording in order to calculate the rotations per minute of the final 10. From there, I doubled the frequency and returned using the Arduino program and ran through the whole experiment again for each individual trial. Now, there are some limitations to this that prevented me from actually completing this experiment. The first one being that the Arduino program was poorly interacting with the school computer operating system in the laboratory. As such, it was a long, drawn out process of trying to get the program to work, trying to get the individual lines of code to function properly, and attempting to actually download the program, as well as trying to get all the files in place that were necessary for it. Second were the delays in the actual arrival of the materials. It was a long, annoying process, including a few clinical errors by the distributors, clerical errors by the distributors. Three was a poor knowledge and lack of experience on my own part in both welding and wiring. And as such, the actual levitator was only able to levitate objects for a few seconds. And as such, I didn't have the time or the power in order to collect the data I needed. 4, the apparatus pieces were constantly falling apart. These miniature speakers were constantly falling out of the ultrasonic levitator whenever I got back to it. Whenever Number 5 was the COVID-19 virus itself. Due to COVID-19, I was unable to return to the MaST lab to get the tools, the resources, uh, or the expertise I needed in order to readjust the apparatus in order to make it more powerful and more effective. And as such, I was unable to levitate anything for more than a few seconds at a time. And thereby, I was unable to complete this experiment. However, my expected results are as follows. Were my goals unmet, that would mean that a change in frequency created either no differences in the rotations per minute or insignificant differences in the rotations per minute. However, if I had met my goals, this would mean that a change in frequency would have had to create significant differences in rotation per minute. What this means is that should my goals have been unmet, this experiment would provide sufficient evidence to show that the frequency does not have an effect on an ultrasonic levitator's cargo. And as such, researchers must look into different designs, such as having speakers in every direction, or other factors to increase stability. However, if my goals were met, this experiment would show that a change in frequency does change the stability of the cargo. Not only that, but with this knowledge, new innovations could make ultrasonic technology more viable and widespread. And even if that was far, far into the future, something that would be immediately apparent would be the creation of a baseline frequency, which optimized the effect of the ultrasonic levitator, and as such, would be able to immediately be applied to any and all applications and experiments from that point on. Thank you.